data preparation in AM Studio, I have another video, is summarized in this 7-minute video roundabout. And what is the data preparation workflow in AM Studio? So at first, you start in the area where you can select a certain machine, and this machine's job floor or a machine floor can be adapted by the user in the settings area. And this is the first thing that we are also want to do in the when we start the training. I can add a new machine from different machine vendors which are available up to now. So we are trying to explore the machine vendors release per release. You can enter some parameters like the costs per hour of the machine, the scanning strategies which are available, and so on and so on. And then I have a new machine available. I jump into the environment of AM Studio, load a part. First thing, I have to be secure that the part is a valid one, which means there are no errors, no defects, no open edges. And one of the biggest tasks in the data preparation is to find an orientation, how a part should be printed, in which orientation. And therefore, we developed a tool which is called Orientation Map. And I will go on to that in details later on. So you can find good and bad orientation based upon different criteria, and simply drag and dropping the cursor into a green area, you will find an orientation of your part which you are feeling comfortable. Here's another part. Again, orientation maps are used for finding the correct orientation of the part. You can then manually adjust the parts as well. But next step is, when you have defined the orientation of the part, you have to support the part, which means these support structures are necessary for a good printing result. Details on that will follow as well later on. So I selected some areas where I want to put specified support types. In this case is a cell support. And for all the other support regions which are detected by our software, we want to use a tree support structure. They are automatically then generated. Then I'm finished with that. That's the second part that I have applied. So again, we have to define the support structures here in the area. Here in this drilling hole, I also want to use the tree support. And here on the bottom area of the part, there are some small areas where I want to use the block support. So we offer different support strategies depending on the support area, which are good or bad choices. As soon as I'm happy with the supporting, I have to jump to the next step. So what you always can see here on the top, there is this guided workflow. So you begin with orientation. Next step is supporting. Nesting is more or less making multiple copies out of that. Build structure is the assigning of the slice and hatch. So how the machine is performing a certain part. And the last step is the visualization of the results. There are two ways to make multiple copies, an automatic and a manual way. Here the multiple or the automatic way is visualized. This is an iterative process, so it tries to find a solution for the problem that I have defined. So how many parts should be positioned on the base plate and stuff like that. Manual repositioning is sometimes necessary. So here you can see that parts are red, which indicates that they are out of the base plate or out of the build chamber. And some smaller adaptations are necessary. And then I'm good with the data preparation. Next step is build process, or a build structure, which is subdivided in 2 steps. There's a simulation tab and a build strategy. Simulation is we implemented the functionalities or some functionalities from SIMUFACT Additive in AM Studio directly. And this is very beneficial for our customers because they can run a quick simulation to get a feeling of how the part is deforming during the process. It's not the most accurate simulation, therefore the user has to buy, or the customers have to buy, the SIMUFACT Additive full version, let's call it in this way, or full product. We only implemented a subset of SIMUFACT here in our solution, but yeah. Based upon the simulation, I can react on critical areas, for example. So here was identified that there are some areas which have a lot of deformation in these areas. So we added additional supports here, so rod supports as they called. And then we can rerun a simulation and we will find out that it's now better. So this is the way to go. Then I'm comfortable with the data preparation. The orientation is done, the nesting is done, the supports are positioned, and normally the users are having available slices and hatch profiles, which is more or less how the machine file is generated. So how the slice thickness is, how the laser paths are generated and stuff like that is defined in these profiles, and they are coming from the machine vendors normally. You can have a look at the output, and when you are comfortable with the preview, you can click on generate, or you can do some adaptations. Then you click on generate, and then the slicing and hatching is performed, and you will get the output. This is the last step in AM Studio. So you can now see all the slices, all the vectors, so how the laser will scan a certain part in a certain layer is visualized here. Exactly. For some machine vendors, we can, in the actual version, calculate the build time. And you can see here on the right-hand side a graph how the build time is over the layers. The build time is calculated, and you can slide through all the vectors, how they are scanned. Yeah. And last but not least, for some machine vendors, we can do a cost calculation based upon the build time and the machine hour costs, which we implemented in the settings area, and the consumption of material. We can calculate the price of this job based upon the settings which were defined, and that's what we are doing in AM Studio, and that's what I want to show you in the next